So let's get started with what is an air mass. An air mass is a large body of air. It's got similar temperatures and humidities throughout that. We have to have certain source regions, and those source regions are fairly intuitive. They need to have similar surface coverings. They need to have flat, like terrain. Those source regions are going to generate air that is relatively still moving, and it can result in some form of stagnation. So whenever you see those types of terms that are called like stagnation or still air, it's somewhat like that of a fog situation, except on a much larger scale, and it's not moisture necessarily exclusively that we're tracking. It is also air temperature as well. So here's our major source regions. We have several. We have some that are oriented over maritime processes, and if it's farther north, we're going to refer to those as polar. So there is a symbol system that is affecting each one of these, and by a quick glance, you can see how we have a lowercase letter in front of an uppercase letter. Two types of things we gather from this is humidity and temperature. So when I say continental, like with the continental Arctic air here, that C tells us that it's dry because it's over a continent, and then the A tells us that it's cold. We have four major ones here that we'll look at, and they are the ones in the red and blue. We have the maritime tropical, we have the maritime polar, and then we have the continental polar and the continental Arctic, and then we have a continental tropical. So those are the big ones that we see. The two that will affect our region, as we mentioned before, is the maritime tropical, and then we get this continental polar that comes in. So what we see affecting us with our storm seasons and snows is continental polar, and then we definitely have the input of maritime tropical air that fluctuates over our region. Here's how we classify these. There's 5 symbols we need to understand. PAT MC, polar, Arctic, tropic are the uppercase, so where we see those, and then we have the 2 surface areas, maritime and continental. So this is the ideas that we've got to put in certain combinations, and those combinations are expressed here. Not a difficult task, nothing overly technical. We have continental polar, continental Arctic, continental tropical, marine Arctic, marine tropical. Sometimes we'll call this maritime. This text happens to refer to that as marine, but do work on these types of combinations. So when we see continental tropic, we have a warm and dry environment, and that tells us about 2 things. All these tell us about 2 things: the humidity level and the temperature level. Whenever they move over the ocean, we have a significant change that takes place. Again, more intuition is involved in this, and that's where we see the evaporation from the water being transferred, and then the air mass sometimes is cooler than the surface. We're going to use special things like sub letters within the order, and that's going to be a 3rd level indicator like a K and a W. So this is not quite as intuitive, but it's typically well absorbed when you apply the thought. But when an air mass is cooler than the surface, we're going to say K is adding to the symbol. So that tells us a little bit about the temperature difference, and that can be useful in some fog bank anticipations. If the air mass is warmer than the surface, we're going to add a W. So the W is intuitively connected to the warmer. K is not intuitively connected to colder. But remember, we're already using a C in the system, so using a second C would be a bit of a unnecessary confusion. So this genesis of this K came from needing to say cooler, but the lower case K did not overlap with the previously used letter. Continental polar, the continental Arctic, these things, during the winter, air masses are dry and bitterly cold. When we have a continental polar, during the summer, it can be continental, and it's going to be a little bit warmer and moisture, and that's where we're going to be still cooler and drier than maritime tropical. So we do see these types of move into play. Continental Arctic is going to be a very noticeable change in our atmosphere, very dry. Sometimes we have these air masses come through, and it really challenges our freeze points in the ground. You do have this chart in your textbook. I'd recommend reading through these. Make sure that you can identify these types of descriptions, okay, within this column. Those are pretty important. We definitely need to be able to understand the combinations here, and then the associated weather here. You should be able to make connections between those. The stability in the regions, not so much. In the source region, we're not going to get too specific with geography, but we do need to make a connection between these air masses and the temperature and characteristics, and a little bit more detail about those temperature characteristics in regards to the associated weather. So those are going to be the things that we do connect to the most. Lake effect snow is certainly connected to these, and we will look at a kind of a side presentation of this in class. And what we see here is an unusual event that has affected us in some recent years, and not necessarily with a drastic amount of snowfall, but we do get sometimes a very speedy front moving through here. That's an Alberta Clipper, and those are lake enhanced at sometimes, especially with the Great Lakes. They don't implicate us with great detail, but sometimes they do pick up a little bit of moisture. Now, if we shift our focus to like Buffalo, New York, and we get on the eastern side of the Great Lakes, there is some unbelievably large snow generation that takes place as these air masses move across these waters, and they pick up moisture. So whenever we're looking at autumn and early winter, we've seen this sometimes even in late winter. Continental polar air mass is going to move over a Great Lake. That Great Lake is going to have greater moisture capacity to it. It's going to increase in temperature. Remember, it doesn't cool nearly as fast. We're still connecting to that specific humidity. It's going to pick up that moisture, and then as it moves over land, and we're talking about the east coast of the Great Lake, then it's going to generate and drop massive amounts of snow. So how much snow are we talking about here? Well, in cases in the past, we've been 6, 7, 8 feet of snow, and some isolated incidents higher than that. So when we have our discussion in class, I'll show you some more picture-based slides, and it's pretty remarkable what type of snowfall can take place over a period of 24 or 48 hours with these lake effect snows. They're some of the most aggressive snows at those latitudes on the planet, and they certainly are nearly at the top of the planet of all snowfalls in that range. Here's a diagrammatic view of what takes place. So Buffalo, New York typically gets a lot of headlines. When we get into Pittsburgh and we get into the Virginias, we can see a little bit of that, but our snow belt regions are certainly east coast of the Great Lakes. So if you want to think of the eastern edges of those, that's where we're having that continental polar move across, and as it picks up these types of moistures, and then it piles up a little bit on the eastern side of that, a little bit more friction, then it's going to snow, and that's going to create an amazing amount of snow within that. Do notice when we are talking about temperature profile, it's pretty significant. We have a subsurface temperature of land at about 18 below zero on the Celsius scale, and the Great Lakes hover 1 degree above. And that's a pretty significant difference, and allows that long wave radiation to implicate that atmosphere a bit more. So overall, we see some general properties of air masses that are introduced here. There's nothing that technical. Some of the things that I would really encourage you to work on is these symbols that take place in this chapter. This is a brief study for us. So do take a moment and read through these. I'm not going to spend a bunch of time going over some things that you all have the capacity to read. Probably the only thing that we need to pay particular attention to as far as specific process in this part of the course is where they originate, what a source region is. The K, when we have the air mass moving over a substance or move over a surface and is cooler versus warmer, that third level indicator sometimes is a bit of a hurdle for us. It's not technical. It's just that we don't dig into the content that deep enough. And the snow that are lake effect snow, so sometimes they're a little bit different. So do read through these. Make sure you're familiar with them. We see these types of things, and they do produce a very visual aspect in the atmosphere, like this slide shows. And sometimes we can have a unusual event with maritime tropical air that's stated at the bottom of this slide. And this is what I'd like to end with in this presentation. The Pineapple Express has brought some drought relief recently to California. Unfortunately, it also deals with some landslides and flooding. but it's an easy to remember name, obviously, for the Pineapple Express, and it flows over Hawaii, which is where some of the origination of its name comes from. So this North Pacific Maritime Tropical Air is going to flow here. And as it does flow over that land, over toward the land, it's going to pile up on the coast, and it really is able to generate a pretty intense amount of rainfall. It's not overly heavy rain, it just doesn't stop. It just keeps churning. It's a very significant conveyor. So for this year that the recording is made in, at the beginning of the year and at the end of last year, we had some significant drought relief. It was a very good thing. So other years it has been a problem because they haven't had such dire droughts, and that wasn't the case. It actually was quite a benefit outside of the intensity of the rainfall being just all in one area. It wasn't super heavy downpours. It was just the duration of the event, which was impressive. Finally, continental tropical, here is what we're going to end the slide group with. Again, nothing overly technical, and that'll do it for this presentation. So with this chapter, it's brief. We're only going to spend a couple days on it. We will have one reinforcement activity. It is geographical. It is very intuitive as far as how these play out. But there's three things in this chapter that I would really encourage you to focus on. That is your first level indicator, your second level, and your third level indicators, which are your first level indicators would be your lowercase like M as in Mike, which would be maritime. And then you have your second level indicator, which would be like maybe a capital T, and that would be a maritime tropical or continental tropical. And then if we put a W or K, we move into our third level indicators. Those things help us describe the air mass and the differences in the temperature that are associated with those. The Pineapple Express is something that's going to be new. You've probably not heard of that before unless you caught those national headlines here over the past handful of months. And then the other thing that gets a little bit pesky is the source region. What are we talking about with the source region? What are the characteristics? Everything else is just good old-fashioned learning. Make sure you get in there and you understand what type of air mass combinations are associated with certain weather and what those characteristics are. So if you have any questions, feel free to bring them up in class. Otherwise, that will do it for this session. What's up next is your next session will be a more complicated section, not overly so, but one that will challenge you much more than this. This is a brief session that will not take a great amount of time. So keep up the good work, and I'll see you in class.